Hi guys, so today you're going to learn about something called alkenes and alkynes. Now you might remember that sounds something similar to alkanes that we've learned about a few units ago. Remember, those are organic compounds. They contain carbon and hydrogen, and they're hydrocarbons. They only have C and H. So alkenes and alkynes are kind of similar, but there are going to be some differences. So for something to be an alkene, it's an unsaturated hydrocarbon. And unsaturated means that I could put some extra hydrogens in there. Hydrocarbon means it only has C and H. But because it's an alkene, it has a double bond in it. Alkanes only have single bonds, so that's a difference. So you remember our organic prefixes like meth and eth and prop and bute and on and on and on. So if I thought about the first one, meth, and then I added this ene ending, methene is actually a chemical that doesn't exist. So it's kind of a trick question. In order to have a double bond, I have to have two carbons, and meth prefix only means one. So it's impossible to have a double bond when you only have a single carbon. So the prefix will tell you the number of carbons, and for the hydrogens, whatever that carbon number is, you're just going to double it. Okay, so let's walk through some of these examples. Since methene doesn't exist, let's talk about ethene. Eth, the prefix means 2, so that means 2 carbons. To figure out the hydrogens, I'm going to multiply 2 times 2, so there are 4 H's. Prop is the next one. Prop means 3, so propene is C3. To figure out the H's, I'm going to multiply by 2 and get 6. Now, if I was going to draw those, remember carbon always forms 4 bonds. So I'm going to take these 2 carbons, but because it ends in ene, I know that I have to have a double bond in there. And then all I have to do is give each carbon 2 more bonds. So this carbon has a total of 1, 2, 3, 4. This carbon needs 2 more, and on the other end, I put my hydrogens. So there's a drawing of what ethene looks like. Could do the same thing for propene. Now I have 3 carbons, and it doesn't matter where I put the double bond, I'm going to put it over there. And then the next job is just make sure that every carbon has 4 bonds. So I have 1, 2, 3, 4. This middle carbon already has 3 bonds, it just needs 1 more. And this carbon on the end needs 2 more. On the other end of each bond, you're just going to put a hydrogen. So I have 1, 2, 3, 4, 5, 6 hydrogens. So if you draw it and you get the same number of hydrogens as your formula, you know you did it right. Let's try a few more examples. So bute would be the next progression. Bute means 4, so C4. To figure out the hydrogens, I have times 2, so H8. See if you can figure out pentene. Pent means 5, so 5 carbons, and H10 because you're just going to double it. Now we'll draw each one of those. So bute, I'm going to draw my 4 carbons. Again, put the double bond anywhere, it doesn't really matter. And then fill up so every carbon has a total of 4 bonds. 1, 2, 3, 4. Then you're going to put the hydrogens on each end and make sure that you get to 8. 5, 6, 7, 8. There's butene. Now, say you drew yours differently. If you decided to take this double bond and it ended up over there, that's totally fine. It's still going to come out with 4 carbons and 8 hydrogens. It honestly doesn't matter, so that's fine. Pentene, I'm going to draw 5 carbons all together. We'll put the double bond at the beginning this time. Again, it doesn't matter. And then we're just going to make sure that every carbon has 4 bonds all together. Carbon always forms 4 bonds. We'll put H's on each side. And then at the end, we're just going to count, and we got to 10 H's. That's how we know we did it right. So let's write out the rest of these names. Hexene, heptene, octene, nonene, and decene. Now I'm not going to draw all of these structures because it's going to get to be too many carbons and hydrogens, but we can figure out the formula for each one. So hexene means C6. To figure out the hydrogens, I'm just going to double that and I get 12. Hept, the prefix means 7, and 7 times 2, there are 14 H's. Oct means 8, so C8. To figure out the H's, I just double it and I get 16. Non means 9, and then to figure out the H's, I do 9 times 2, which is 18. Dec means 10, and there are 20 H's because I just have to double that. We don't need anything in this box. So those are all the things you need to know about alkenes. Now let's talk about, well, what is an alkyne then? So it's kind of the same. It's still an unsaturated hydrocarbon. I could break those bonds and add hydrogens, but I'm not going to. But this time, instead of a double bond, alkenes have a triple bond. Okay? So again, that methyne doesn't exist. I would have to have 2 carbons to put that triple bond between, and meth only has 1. So there's no such thing as methyne. For all the other versions that we're going to draw, the hydrogens are a little different. Now we're going to do times 2 minus 2. So let's talk about a couple of those. We're going to have ethyne and propyne. Let's figure out those first. Eth means 2, so that tells me 2 carbons, whereas prop means 3. In order to figure out the hydrogens, we're going to do 2 times 2, which is 4, minus 2 is 2. So C2H2 is ethyne. Propyne is C3, so 3 times 2 is 6, minus 2 is 4. Let's try to draw each one of those and make sure that that makes sense. So ethyne, I'm just going to have my 2 carbons. They have to have a triple bond between them. And then each carbon needs to have 4 bonds all together. So that looks terrible. Let me make this neater. Nice, neat triple bond in there. Okay. Now every carbon has 4 bonds. I put an H on each side, and that only requires 2 H's, so I know I did it right. Try propyne. 3 carbons this time. Doesn't matter where the triple bond goes. This first carbon has 3 bonds, so it needs 1 more. The middle carbon already has its 4, and this carbon on the end only has 1. So I'm going to do 1, 2, 3, 4. When I put those hydrogens in to fill up the other side of those bonds, that requires 4 hydrogens. So that's how I know I did propyne right. Let's try some more. Let's keep going. Let's do butyne and pentyne. So but means 4, so C4. Times 2 minus 2, for the H's. 4 times 2 is 8, minus 2, there are 6 hydrogens here. Pentyne is C5, pent means 5, times 2 minus 2 is H8. Now let's draw each structure and see what that looks like. So but, I'm going to have my 4 carbons. I can put the triple bond anywhere, it doesn't make a difference. And then every carbon needs to have 4 bonds all together. So this first carbon has 1, 2, 3, 4. Both of these center carbons are already full. They have their 4 bonds. And this one on the other end needs 4 bonds like that. When I put in the hydrogens on the other end, there are my 6 hydrogens that I knew I would need. If I do pentyne, I'm going to put my 5 carbons in a row. Let's put the double bond or the triple bond here at the beginning. Doesn't matter. So then I just want to fill up. So every carbon has 4 bonds. Well, this first one is done. The second one is done. 4 bonds there, 4 bonds there, 4 bonds there. When I add in my hydrogens, there are the 8 that the formula told me that I needed. All right, let's talk about some more formulas. If we keep going, we have hexyne and heptyne, octyne, nonyne, decyne. I don't need anything here. Okay, so let's see if we can figure out these formulas. I don't want to draw all these C's and H's because I think you have the idea. Hex means 6, so it's C6 times 2 minus 2 is H10. Heptyne means 7. Times 2 minus 2 is H12. Oct means 8, so C8. 8 times 2 is 16, minus 2 is 14. Nonyne means C9. For the H's, because it ends in "ine," I'm going to do times 2 minus 2, which is 16. Lastly, decyne is C10, H18. All right, so now let's talk about, well, how do we put all of this together? We've been talking about organic for a while, and there's kind of a lot. So this chart is going to be a bit of review for you. So organic compounds, they have to have carbon and hydrogen. That's the basic definition of organic. That's all that it really matters. Now there's two options. Some organic compounds have CH, and they can have other elements in them. So maybe you remember from bio learning about CHO, CHON, CHOMP, right? That's CH, and then they combine with oxygen, nitrogen, phosphorus, other things. Another very common one is to have carbon and hydrogen, and they like to combine with the halogens in group 17. They're still organic because each one of these has CH in it. It's okay to have other stuff in there. When we only have hydrocarbons, though, that means that it's carbon and hydrogen only. There's no oxygen, there's nothing else in there. It's C and H only. The hydrocarbons are what we were talking about here, the alkanes, alkenes, alkynes. So, why does all of this happen? Carbon is a super important element to life. Basically, it's the reason you're alive. It is a foundational element for life and many other chemicals that we use every day. And that is because of its bonding scheme. The way that it forms bonds is very special, okay? Every time we drew a carbon up above, it had to have 4 bonds. Now, those could be 4 single bonds. We could have carbon and it has a double bond, and then it would just have 2 single. Or we could have a triple bond and then 1 single over there. But however you do it, every time you draw a carbon, it has to have 4 bonds. That's what makes it so special, because it can do all those different combinations to make its 4 bonds. Now, hydrogen's just kind of easy. It always forms 1 bond. So whenever we kind of need a leftover, we just stick hydrogen in with a single bond coming off of it. Now, all of these organic compounds that we're talking about use these common organic prefixes that we've learned before. Those always tell you the number of carbons. So we're just going to write these again. Remember, it goes meth, eth, prop, bute. Remember, Maria eats peanut butter. And from there, it's the regular prefixes that we're used to. Pent, hex, hept, oct, non, dec. And then we'll write meth means 1 carbon, eth means 2 carbons, prop is 3, bute is 4, 5, 6, 7, 8, 9, 10. So all of these compounds down here all use those prefixes. So that's nice. You don't have to memorize any different ones. Okay, so it's something that they have in common. But let's talk about what is different between alkanes and alkenes and alkynes. So in an alkane, you can only have single bonds. In an alkene, you can have a double bond. And the rest will be single, but even if you just see 1 double bond, it's an alkene. And in an alkyne, it has to have a triple bond. The rest will be single, but you'll see a triple bond in there. Now, the fact that alkanes only have single bonds mean that they are saturated. That basically means that they are as full of hydrogen atoms as they could be. All of those carbons are connected to as many possible hydrogens as it could be. But alkenes and alkynes are unsaturated. What that means is I could add more hydrogens. If I broke the triple or double bond, I could stick some more hydrogens in there. That's what unsaturated means. Room for more hydrogens. Now we need to talk about how to name all of these things differently so we can tell them apart. If they all use these same prefixes, the difference must be the ending. So here, for an alkane, the names end in ane, just like the word. Alkenes, the names end in ene. And alkyne, the names end in ine. So it goes with the name of the compound, so it's easy to tell them apart. The last thing is, how do we figure out the number of carbons and hydrogens for each one? They're hydrocarbons, that's all that's in it, so how do we know how many? Whatever the carbon number is, you'll know that from the prefix, again up here. And then to figure out the hydrogens, for alkane, it's times 2 plus 2. For alkene, you just double it. And for alkyne, it's times 2 minus 2. So that's everything you need to know about those organic compounds and the hydrocarbons.